Okay, welcome back. Episode 20, Spitfire Engineering. This week, we put the pallet conveyors together. We do some more work on the Mayglass trommel, which is no longer in the workshop now. And we have a bit of a disaster with staff. So it's a new week and I'm back in the workshop. We've done some more work to the IBC drain down tank. So let's flip this round and I'll show you what we've been doing. So this has been flipped over now and we've now got the frame on the inside. Now if you look, the frame doesn't sit level. It sits at an angle at the far end. And the idea being that as they put the IBCs on, they're slightly tilted over so they can drain out. Now making the tank, we have it has slightly warped on the sides in the welding process. So we've got a piece of box section clamped up here to hold it back straight. This side's looking pretty good. So that holds it straight so we can weld in the internal frame. And then this frame here is what the waffle boards, as I now know they're called, sit on. And then the sump at the far end is now in. So that's the sump at the back, at the bottom. We've got two holes just here, if you can see them. That's where the heating elements are going to go, and we've got the flange on this end ready to take the oil away. And then once these are welded in here, we can then drop this into the frame and secure that into the frame. So on the recovery body on the bottom, we've welded it up, and it doesn't matter how careful we were, you can see we've got a slight warp. So what Steve's doing now, he's welding a couple of posts each end. So he's going to weld a post there and a post this end and put a beam across the top. And then we've got a bottle jack and we're just going to try and manipulate it back down. Can't go crazy with it, but we're just going to try and manipulate it back down and make it a bit straighter. That was all, there's gussets inside there, that was all tacked up nice and straight and welded up in a sequence that we thought would eliminate any bow in there, but it's still got a bit of a bow in it. It's all pulled a little bit. So we're now going to try and manipulate it back into shape by using 3 bits of box section and a bottle jack. So let's see how we get on with that then. See how successful we're going to be. So this week's been a bit of a trying week. Lots of things going on. We've interviewed 3 people this week for new positions. We've got 2 people on a trial day today. Off the back of that, we've got one one guy going out with jam on the service van because the customer that jam does a lot of work for, they've rung up and said, "Can you put another van on the road?" So we've got a guy. So sometimes these things happen by fate. We had the phone call on Monday to say, "Can you put another van on the road?" A CV come across her desk on Tuesday, I think it was, this week. Somebody that had got the relevant skills to do that job, just been made redundant from another job, so he's available immediately. So we're just doing a trial day with him today to see if he suits what we want and see if he wants to come and work for us. So if that comes off, he'll start with us, and I'm going to have to go buy another van, more expense. So that's quite positive. That's quite good. We've got another guy in as a general operative this week to work in JMO's team to do final assembly and paint, that sort of thing. So he's doing a day's trial today. Today's Thursday. I'm a bit behind on filming this week with what's been going on in the office. So that's all positive and moving us forward in the right direction. I've also had to let somebody go this week, which is not a job that I relish. But if anybody's been in my position where you employ people, sometimes that happens. Somebody was in position that probably wasn't suited to that position, which is unfortunate because he's a nice guy, but it wasn't working out. So we've now parted company this week. So that's where we are with that this week. Let's go and have a quick look around the workshop and see where we are with some of these projects, because they've probably moved on a little bit since the last time we saw them. So the recovery body's coming on now. Managed to straighten off this bottom end a bit from where it was bent the other day when I showed you. Steve's got the tie down points welded in now. We've now still got some bosses to go in these round holes. There's 2 each side. And what they're used for, the customer's got like a snatch block to go in there. So if he needs to pull a car on at an angle, he can put a snatch block in these holes here. There's one there and one there, same both sides, so that he can straighten the vehicle up and get it on. But this is nearly done now. Got all the checker plate welded in. Still got some holes down the side which are going to have some plates welded in so that ratchet straps can secure the car onto it. In the end, we ended up using the original headache rack, so Steve's cut the headache rack off of the old unit. So we've managed to salvage that. He's now just about to weld that on. The top section goes in these cutouts here that have been cut out. So there's a roller that runs in that channel there. So as the lift goes up, there's a roller that runs in that channel that's on the end of the top section. And then what we'll do is we'll weld them in. We'll weld a plate over this end and tidy it all up so it all looks original. So that's coming on well now. And I think what Steve's got to do now it's all been done on top, we're going to lift it up, put it on trestles and just get underneath and stitch weld these plates in place underneath. Because at the minute this checker plate is just welded on top. And it's got some tacks underneath, but he'll go underneath and just finish welding underneath. And then once he's done that end there will be shot blasted back to bare metal, so it can all be painted as one. There's still a plate to go at the front where the winch goes. Just watch your eyes. So there's a plate still to go at the front, and then when that's done, that can go out, be shot blasted and painted, and then Steve's going to start making the top deck that goes on top. So hopefully by the end of next week, this will all be somewhere near being finished. The oil tank that I showed you earlier in the week is nearing completion, but we have made a mistake. We've welded in the frame that the IBC sits on. And I come out here earlier on in the week and said, is that angled the right way? Because I thought it was going the other way. Looked at the drawings and the way that the drawings have been done. It looked right, but actually in reality it wasn't. George had done some sort of extrude, which means instead of actually having the full tank like this, he'd done like a cross section of it, and they'd used the 2 holes down the bottom there for the heating element as the datum, which sort of gave the impression that we were looking at it from the far end. But because he'd done it so that this end here wasn't here, and because they'd used them 2 as the datum of which way round it was, because obviously if you're looking at the drawing from this end, you'll see the flange here at the bottom. If you were looking at it from the other end, you'd see them 2 holes at the bottom. So there was a degree of confusion over that, and it's been welded in the wrong way. So we've had to cut it out. It's now going to be cleaned up, because at the minute it was sitting from top that side down to low this side, and actually it should have been top this side down to low this side. So it's an easy mistake to make, and you can guarantee if there's going to be a mistake like that, we'll make it. You got to look at it from the point of view that the stuff that does go right, you don't talk about. You only find out about the stuff that goes wrong, but it's not the end of the world. On this job, it's actually gone together faster than we thought, so there is still time in this job, which isn't the point. It's nice to always gain a bit of time on some jobs, because plenty of jobs still go over. But it is what it is. So the frame is there on the floor. It's been cut out. It's been cleaned up, and it'll be put back in the right way, and then we'll just move on with our lives. So that's that. The pallet conveyors are now being assembled, because we've got Sean, the electrician, coming next week to wire these up. And what we want to do is we want to lay them in the workshop. So we've got 1, 2, 3 in the workshop, and then there's a 90-degree transition that will go at the end. Sean's coming in next Wednesday, not Wednesday, Tuesday I think he's coming, to wire these up. So we've started putting these together. This one's got the chain on. So you can see the chains running on here. And as I've said before, this is special chain from the point of view that the rollers are offset. So the rollers here will roll along the channel, and then the plates are higher than the rollers, so the pallets will sit on top. Pallets will go across the 3 chains. The rollers at the bottom will roll along, won't be interfered by the pallets sat on top. So the lads are just assembling that now and putting them together. And I've showed you these before. There's a gearbox that's going to go on this shaft here, and that will do the drive. So there's 3 of these sections going to fill the workshop up. All right, Dan. Magic. So they're going to go down here and hopefully run them up next week. The Mayglass trommel, Sean was in yesterday and wired this up. We had it running, everything's looking good. So Sean's been in, we've got the control panel here. All wired up. And then this control panel, once this is up on its legs and on its bunkers, the control panel will be just down here, which is where the customer wanted it. So there's enough cable in there. In transport, this control box will just get cardboard wrapped around it and strapped onto the frame. And then when we get to site and get it up in position, we just lift it down and bolt it onto the legs below. So that's now all been wired up. We've got HIAB coming in on Monday next week. We've got Hampsons coming in. We've got 2 HIABs in the yard next week. Because, drum roll, the new offices are being delivered next week. In fact, the offices will be in the yard tomorrow afternoon. They're coming in to us tomorrow, and then the guys are coming to install them on Monday. So we've got 1 HIAB in the yard on Monday to put the offices together, and we've got another HIAB in the yard because the oil screens for the Birmingham Oil Company. They're going out on Monday and being installed. So a lot of activity in the yard on Monday, truck-wise, 2 Hiabs, 3 Arctics in the yard for all the offices. So yeah, Monday's looking like a busy day. So we're going to get the panel work put on this now, and then this one will get moved outside so we can continue down here with the pallet conveyors, so we can get them wired up on Tuesday and do a test run on them. Because what we're going to do is we're going to test these in 2 phases. So the way that this works is there's 3 of these sections, 1, 2, 3, and then there's a 90-degree transition. That will be phase 1 of testing. And once we're happy with that, these 3 chain sections will get put outside and stacked up. And then the other sections, which are the roller sections, we will go 90-degree transition. And we'll probably, the 90-degree transition that will be down here will get moved to the top of the workshop, so we can go 90-degree transition, and then the roller bed comes down. It does a sweep in 45 degrees, so it kicks across for about 2.5, 3 meters, and then it continues down here. So we're testing it in 2 phases because we've looked at it, and it's so big, there's nowhere around here that we can use to actually put it all together in one hit. So we're going to test it in 2 phases. There's all sorts of sensors and controls to go on it. As I said before, this one's having a walkway across because this one's got the tabs on it. So there's walkway to go across here with a set of steps each side. So there's a lot of control and automation on these, which, as I said earlier on, we'll go into detail more when that's all up and running, and we'll show you how that works. That's probably going to be in next week's episode. Because, as I say, Sean's in next week. We'll get it all wired up, get it tested, we'll get it filmed how it all works while we've done it the way that we've done it. And that should hopefully make a bit more sense then. So when I was just talking about the 45-degree swept bits on the roller conveyor, this is what we've done for that. So we've got 2 sections that are going to sweep at 45 degrees, and Connor is just making up the side sections for this. So it's basically a rolled piece of steel with a flange welded top and bottom, and that's going to give us our curve for the rollers. So he's going to weld them up now. There's an outer and an inner. This is the outer. There'll be another one at the bottom there. And then there'll be rollers between them, and it'll take it from going straight, and it'll sweep it round into a 45 degrees because we need to put like a bit of a dog leg in the roller conveyor run. So Connor's just making them up now. Hopefully have them done today. Colin's been busy cutting in the metal cutting room. We've got 2 more mini screens going through the workshop. So we've got all the box section cut for the frame. Round tube that we use. This round tube here, the fairly hefty stuff, that's what the vibrating motor attaches to. I think if you're a regular viewer of the channel, you'll see that's been used in the past. That's the tube that we use. It's fairly hefty, so that doesn't break. We've got the T-bar that is part of the cassettes inside. Chutes off the end. Side panels for the actual box itself. Got the mounts here for the vibrating motor. The vibrating motor goes on here, these 4 bolt holes here, and then they fit. I think we've done this before, to be honest. If you've seen this before, you'll know what I mean. That goes on there, and then that bit of tube I've just shown you slides through 3 of these plates, and that's what attaches the vibrating motor to the actual screen box itself. Tension bars here for the actual screen box, sides for the actual cassette inside the screen box. So yeah, there's a lot of material here cut for 2 more mini screens that are going through the workshop, because as it stands at the minute, we are out of stock. Last one went out the other day, but it is coming towards, it probably is the end of screening season now, so we'll make these machines up. These probably, they might go this year or it might be next year when they get sold, but we'll get them made up for stock anyway when the lads in the workshop get a chance. So a few weeks ago, my semi-retired friend from the southwest, I was talking to him on the phone, and he said, it'd be really interesting to see how we go from a sketch and drawing it and actually inputting that into our CNC plasma. So you can see the process. So if somebody comes into us with a sketch saying, can you cut this out for us? How would we go from the sketch to actually the cut part? What's the process? So there's two ways of doing it. We either give it to George in the office and he draws it on SolidWorks, on our CAD software in there, and then he draws it, he then puts it onto a memory stick, and that comes in here and it gets plugged into our Cutavar, our CNC plasma, and then it cuts it out. Or there's another way we can do it on Cutavar, and that is actually we can actually draw the component on Cutavar and actually go through the process. So I thought it'd be interesting to show you the process of how we go from a sketch to a cut part. So I'm going to show you that now. So what we're looking at doing is this sketch here. It's really simple, basically two rectangles to those dimensions. So Archie's now going to do that on the screen, and you can see how it works. So we can do a center rectangle and put in the dimensions of the outer rectangle, and then we can do another center rectangle and put in the dimensions of that. Now if we were doing this in the office, we could actually work out, we could actually do two rectangles and then measure between the inner and outer lines on all four sides and change it that way. But this software out here is a little bit limited in what you can do, so you have to think a little bit outside the box and go about it a slightly different way. So we're looking at cutting those components at a 10mm plate, and this is for the recovery body that Steve's working on in the small fab workshop. So we create the drawing like that, and then what happens next, Arch? Because I don't even know how to use this machine.
We will essentially, so that is one of our parts. We'll just do it for demonstration now. We'll click the arrows at the top there. This is the sheet essentially for our part, so we can tell the machine that we've got 10mm mild steel, and then you can change it all up and down. 200mm, not going to happen here, but we often cut at about 25mm. We do, yeah.
That's the maximum we would.
That's what we would do.
Here.
But then we do cut.
Anything bigger than that, we can get it profiled by somebody else. But 99% of what we do here is less than 25mm, so that suits us.
And then we'll go for the workpiece size. So I don't know. We'll leave it as that for now.
So what we have to do, this is being cut off of an off cut. So what we do is we measure the width and the length of the off cut on here, and we put that information just here. So we tell the machine what size the offcut is. Have we actually done that on this now, or have you still got to measure it?
That's just from the last program that was on there.
Okay, so we'll
demonstration. We'll use
We'll
that.
measure this now, and we'll put the dimensions in, and then you can see how it's going to nest on the piece. So we've measured this now, and we make sure that this piece of steel is on straight, and we normally measure from the plate to the side of the machine at both ends, so from there to there and there to there, so it's straight, because the actual cutter itself wants to work in 2 dimensions, so it needs to know that that piece of steel is not squonky, if that's even a proper word. So we need to make sure that the plate is parallel with the edge of the machine. So we've done that. Make sure that we've got the dimensions, and then Archie puts those dimensions into there, which he has done. So the machine now knows the size offcut that we're working with, and what it will now do is go through, and how many of these do we actually need for this job?
10 of these.
So we need 10 of these. So what the machine will do now, it now knows the offcut or the sheet of steel that we're using, and what it will do now, Archie will now tell it that we need 10. So he's got the count at the top as 10, just there. And then I think when he goes through to the next screen, start nesting. So the machine itself has now said, right, the sheet size is that, you need 10 of these components. This is the most economical way to lay out those components on that piece of steel that we've told it that we're using. If we wanted more than 10, so we wanted 20, it would then tell us we need to go onto another sheet. But by the looks of it, they're all going to fit on the piece of steel that we've got. So we now go through to the next page. So on this setup here, we've got 3 different screens that we use. We've got CAD, which is the actual drawing of the component, CAM, which is the actual nesting of the component and the actual writing of the program, and then we've got CNC. You see it across the top, CAD, CAM and CNC, and then you go through to CNC at the top, and CNC is basically the machine controller itself. So you've drawn the component, you've created a CNC program for the machine, and then it goes through to the next page, which is this, which is the actual control of the machine, and it writes what's called the G code. If you see here what Archie's scrolling, that's the G code. The way it works is it's basically a series of letters and numbers, and the machine knows what that is. The CAM program writes the program into a G code, and then when it goes through to CNC, the machine itself uses that code. It's basically like coordinates on a map. So you're telling it to start cutting here and move at this speed for a set distance across, and then it says change directions and go in a different direction. So it's lots of small up and down, left and right movements that actually control the machine. So now what Archie does is he's going to bring the torch down to the datum point, which as we stand and look at it here is always in the bottom left hand corner of the piece that we want to use. Yeah, you can change that on this one. On the old one, you couldn't, could you? On our older machine, you couldn't. But you can actually have the start point. You could actually have it in the top right-hand corner and then cut towards you. But we don't do that. We always have it in the bottom left-hand corner because that's what we're used to, and everybody knows how that works. So Archie's now gone to the bottom here, making sure that he's clear of this cut here. So we put the torch in this bottom corner here, and we tell the machine that that is our datum, that's our start point. So once it's in, we've manually put it into position, we zero that as datum. So we zero the X and Y, which is your up and down, left and right. And if you see the yellow dot here, that's where the machine is, thinking it is, on the computer, on the machine. And if we look at the piece of steel, that is exactly where it is on the piece of steel. So we've set the datum and the starting point. We've got all the components loaded in. And I think we are now ready to go, aren't we, Arch?
I believe so.
Okay, so we've got 2 buttons. So we've now got this ready. We've got the torch in the right position, the plate's on there, the program's run, it's all ready to go. Now, sometimes if it's an intricate part or we're trying to use the most out of an offcut, we can do what's called a dry run. So we've got a setting at the top here where we can click on dry run. So if we were tight for space on an offcut and we were trying to utilise the space as much as possible, we can do a dry run, so the torch will run through its sequence, but obviously without the torch running, and we can actually watch it and see if it's actually going to come. Say, for instance, we've got a big circle in here and it was tight to here. If we hadn't got the 0 set right and the torch was going to come off the sheet, we can actually watch it and do that, and then we can actually then readjust the 0 to get the maximum out of the sheet. But we don't need to do that on here because we know we're okay. So now all we do, we press the go button. The torch moves itself automatically into position. So I've just got to ask you to stop that. Just pull this component out and you'll see what it's done. So we've taken the sketch all the way through to a cut component. And what the plasma cutter does, it will start cutting. If you see just there, the plasma cutter starts cutting just to the side of the profile, and what it will do, it will pierce outside and it will come in towards the component, so it will come in and it will follow its path around. If you started cutting actually on the line, you would end up with it blowing out. There is a very slight mark there, which isn't the end of the world, but it's just so that you actually end up, you lead into the cut. They call it the lead in. So you lead into the cut, so you end up with as good a cut component as possible. I'm just going to ask you to stop that because it's quite noisy, but that will then run and just keep going from one to the next to the next. Cut quality is pretty good. You do have what's called a kerf with a plasma. If you look down it, you do get a very slight taper. Sometimes when we're cutting holes that we want to put a pin through, we do have to go slightly bigger than what we want because you end up with a very slightly tapered cut on a plasma. If you want a really straight cut, you need laser. But for what we do, that is perfectly good enough. And we don't have a problem. If we want a seriously accurate hole, we machine it out in the mill or on the lathe or whatever it is. Sometimes we can cut a disc in here, and if we want an accurate hole in the middle, we can cut a disc, we can put it in the lathe, and then we can bore it out to a really accurate hole. So that gives you a little bit of an insight into the plasma cutter, how it works. That's a fairly basic operation, that is. When you look at some of these other components here, you can see when it comes to like a radius on something, the machine in very minute detail is actually going left, right, left, right, left, right, left, right. In its own mind, that's what the G code does. But actually in reality, it's just a nice curve. So that's how the lads in the workshop, if they need to just make up some gusset plates or some plates for a job that they're doing, they've got the facility to be able to do it here actually on the machine direct. They don't need to go in the office to see George. They can do it direct themselves. But a lot of the designs that we do here are designed from the office. It comes out on a memory stick, gets plugged into the machine, and what that does, it just skips that first process of actually having to draw the component. It can come straight from the office, plug it straight into the machine, load up the actual code itself, and get the machine running. Thought you'd find that interesting. Okay, fun fact, British engineering style, because we only do British engineering in our fun facts. This week's Did You Know? Do you know what year the Thames Barrier was built in London? Now, when you think what it's used for, it's used to stop London from flooding. Wouldn't have bothered myself, but there you go, that's another story. It's there to stop it from flooding. So you'd think it's quite an age, but actually the Thames Barrier, which apparently is one of the largest movable barriers in the world, that's what it says, was put in 1984. Now, you would have thought that would have been older than that, because surely flooding's been around for a bit longer than 1984. But apparently 1984 was the year that they built it. Built by the British in Britain. Okay, so that's it for this episode. Thank you all for watching. If you've got any comments or questions, I'd like to do at some point a questions and answers session. We do occasionally get some questions, different people saying, but I think what we'll probably do is we'll probably compile some questions, probably get up to 5 or 6 questions, and then we'll do a question and answer session. So if there's anything you want to know about the business, any products we do, anything in the industries we work in, why we do things a certain way, why we don't do certain things, stick it in the comments and we'll compile it and we'll do a question and answer session. So like I say, like and subscribe, as always, doesn't cost anything, helps us out a lot. Also, if you know somebody that you think would enjoy watching our videos, share it with them as well. We'll catch you on the next one. Okay, episode 20, welcome back to Spitfire Engineering. This week, can't remember what we're doing. What are we doing this week? Okay, episode 21.
20.
20.